Good morning, students. Yes, class 12 students, and this is for 4/04/9/2020. So this is for this date only, and topic is Boolean algebra. I have already started with the Boolean algebra, right? And why I am doing this? Because this is a continuation of that part, and you'll find that the important things is the truth table. This truth table, you know, this is tabular structure, and this tabular structure from the table means tabular structure. So you know that truth table will be having a tabular structure of what? Which shows the input. For example, if you are doing like this tabular format of not truth table, so if it is x, or you can write this is x and this is y, so 0 and x bar not x naught, if it is 0 then it will be 1, and if the value of x is 1 it will be 0. So this is in fact a truth table of the NOR operation, not operation, N-O-T, not operation. So, and the particular gate for this is this. So if it is x over here, x bar will be this, and this is the gate operation. So truth table is this one. This one is called the truth table, that is having the tabular form, and this is the logical circuit that you draw of the NOT gate. Now comes to the next part. But before I go to the next part, so you will also be knowing that shows the input value. So this is my input value, and this is my output value. So input value, you can see tabular structure showing the input values used and the output obtained through any logic process. So there is a logic process, the logic gate, that is NOT, and after this process 0 turns to 1 for the NOT operation and 1 turns to 0 for the NOT operation. Now, so this point is clear. Now coming to the point of the logical operators. You know operators, because in arithmetic we have done operators plus, minus. Okay, over here logical operators you will find in Boolean algebra deals with only 3 types of logical operators. 3 types. 1, 2, 3. And these three are nothing but the NOT gate, which I have already shown, the particular AND gate, which I have already shown, and the OR gate, which I have not shown. NOT gate I have shown, AND gate I have not shown, OR gate. So if I come to the AND type of operation, so NOT I have shown, AND is dot. So over here in the logical operation we find that AND, A-N-D, AND if I write, so that means I can do like this. This is the AND logic, x and y, so you give x dot y. This is the AND. And coming to the OR, we have the thing called like this. Okay, so x and y, and this is nothing but the OR, and x plus y. So we have 3 types of logical operators, such as the NOT, AND, and OR. Now, propositional logic, we have to understand what is propositional logic. Propositional logic is a procedure. Procedure what? To provide reasoning. Very important, reasoning. I mean, any procedure with the reasoning should be there through statements. So there should be statements. Okay, and this is the propositional logic. So any reasoning through statements that whether it is raining outside or not. So your answer should be either yes or no. it should be logically true, means 1, and false means 0. Or it can be like this, like if it rains outside, then you should take an umbrella. Okay, now we come to this part. So, a sentence that results in true or false. Now, if this is a case of a sentence, so if A represents that my father is at home and B represents today is Sunday. So if I want to represent this, then I write like this: my father is at home dot and today is Sunday. This is a propositional logic. And then you can find over here very well that sentence that results in true or false now is said to be in proposition. A proposition, whether it is simple or compound, is also referred to as well-formed formula. That is WFF. A question can come, what is the full form of WFF? So the full form of WFF is well-formed formula. So this is well-formed formula. And next, you will find that the Boolean algebra uses postulates, that is a fact or any art of reasoning, and laws in order to simplify an expression. Any given Boolean expression can be simplified. So the one simplification comes. So how you simplify? That is important. So if you want to simplify, you have to know the postulates, that is the art of reasoning, or your facts, and the laws, that is very important. And some of the postulates you find over here, and the laws you find over here are given. You find that 0 and 1 are given below, and this is the properties of 0 and 1. This is one of the particular postulates, that is 0 and 1. So you are aware that the value of any Boolean expression may be either 0 and 1. Did you know? Hence, if 1 is added to the variable, it results in 1. 1 added, see 1 added to any variable, so that variable can be a 0, it can be 1, it can take two states. So if 0, any variable plus 1 is equal to 1, and if any variable that is also 1, you have the digit 1 plus 1 gives 1. In a similar manner, you will also find the truth table over here, which illustrates that if you multiply a variable by 0, the answer comes to 0. So this variable can exist in two forms, either 0 or 1. And if 0 plus into 0 multiplied by 0 gives 0, and even 1 multiplied by 0 gives 0. So this is the truth table over here, this is the truth table. So like this you will study the other laws. And over here there is another thing. So a plus 0 is equal to a. So a plus 0, find it, and a dot 1 or a into 1 is equal to a. This is about the particular postulates, and then you have the laws also. All this you have to study like this. You have to verify using the truth table. I have shown one, there are many. So you have to go through that. Okay? Thank you.